Hi folks, welcome back to Physics with Captain Rod, making this video to help you out with numbers 10, 11, and 12 in Unit 2, homework assignment number 2. I wrote some formulas on the right that I think are going to come up here. Ohm's law, voltage is current times resistance. Calculating power in an electrical circuit is current times voltage, also equal to I square R. That just comes from like solving this for V and plugging it in here. And electrical resistance, remember, is directly proportional to length, falls off with area. The proportionality constant, this thing's called the resistivity. I always have trouble pronouncing that. That's the material dependence. So I think these types of things are going to come up in these problems. So as I look at number 10, and it says a voltmeter across the terminals of a tungsten filament measures 112 volts. The 112 is in red. You probably have a different number. With an amp meter of reading 0.536. So start with just Ohm's law. Voltage equals current times resistance. They gave you a voltage and a current. You can now calculate a resistance. Okay, part B, find the resistivity of tungsten. So, and it is the resistivity at whatever temperature we're at. So resistance, remember, is equal to some constant, that's called the resistivity, times length over area. And these numbers are given in the problem. They gave you a length, and they gave you a radius, which will allow you to calculate an area. So you're going to take the resistance that you found earlier, that's going to go here, take the numbers given, solve for this. Make sure you're consistent with units. Okay, number 11, let's see. Current supplied by a battery is 0.32 amps. Now it's given in red. I'm going to use the value that I have. 0.132 amps. Yours probably will be a different number. And it says find the number of electrons passing through a device in 1 hour. So start with this, right? What is current, right? Rate that charge is transferred. So it's equal to delta Q over delta T. And the 1 hour, right? You should be able to find your delta T. You're going to want that in seconds, no doubt. And that's going to allow you to pretty easily solve for the charge, the delta Q. Again, here, this is number 11 we're chatting about. Now, once you have the charge, let's call it a delta Q, all right? Remember that charge comes in packets. It's going to be 1.6 times 10 to the minus 19th coulombs. That's the fundamental unit of charge times however many electrons. And that'll get you through number 11. All right, give me a moment here. I got to scroll down to see number 12. Okay, number 12, all right, this one over here. Okay, it says the resistivity of copper is given. Now the copper's red and the number's red. You might have a different deal, but I'm going to write this in red. There's a resistivity given of 1.7 times 10 to the minus 8th ohm meters. Again, I'll leave this in red because yours might be different. Part A, find the resistance with a given millimeter and radius. So you're going to use resistance is proportional to length, falls off with area, and basically, you know, that number is going to go there, and length and area are just given in the question. Actually, they don't give you the length, they give you the radius, so you're going to have to calculate the area. Also keep in mind your radius is given in millimeters, so you either need this in millimeter and this in square millimeter. Actually, I'm sorry, meters for both. You want that in meters, and this you want in square meters. Because look at the units on the resistivity. See how you've got a meter there? Part B, calculate the volume of that wire. Well, the wire just, you know, is basically a cylinder. Area is pi r squared times the length will get you the volume. Okay, part C, suppose that the copper is formed into a new length. It's quite a bit longer, 2.32 meters. So what they're saying is basically, what if we stretched this out? Now, the important thing to realize is that stretching the wire won't change the volume. So they gave you a new length. I'll put L final. You have a radius here, pi r squared, or a new area, which is going to equal pi r squared. Now that radius is going to be different than it was before. But the volume, which is our final length, times pi r squared, let me put a final on the r too, is going to stay the same. So whatever volume we got before, you're going to put that here. They gave you a new length. You're going to solve for the new radius. Then when it says find the new resistance, all right, so resistance, again, is resistivity times length over area. Take your new length and your new area. This is not going to change because it's still the same wire. So that's enough on those three. I think I'll call that video good and make another one. Everybody have a great day.